Section 9.3, Absolute Value Inequalities, Sample Homework Solutions. Number 1. The absolute value of x minus 9 is less than 6. Now, if you look on page 565 of your text at the purple box, you will see that whenever big X, which stands for the expression x minus 9, is less than some c, meaning constant, and in this case our constant is 6, then the shaded region would look like the graph below. Would be, if you look to the from 0 to 6, that distance is 6. So the distance from 0 is less than 6. And then you look to the left, the distance from 0 to minus 6 is also less than 6. So all the values for that expression, for which we're finding x, should be included in that yellow shaded region. Now, if we translate that same yellow shaded region into an inequality, we get the equation below. X minus 9 is less than 6 and greater than minus 6. That represents that yellow shaded region. So now that we have our expression set up properly, we translated the absolute value of inequality as x minus 9 is less than 6 and greater than minus 6, we can now solve it. So to get x by itself, we add 9 to all three sides. On the left, we have minus 6 plus 9 is 3. And on the right, we have 6 plus 9 is 15. So this is one way to write your solution. The x that we were looking for, that x that made that original expression less than 6, is any value less than 15 and greater than 3. If we put that in interval notation, we use the rounded parentheses for the less than symbol and the greater than symbol, as opposed to the square parentheses for less than or equal to and greater than or equal to. So this is interval notation. Now I put the graphical notation right underneath the interval notation. The interval notation is the 3, 15. You can see the graphical notation looks very much like the interval notation, where the interval notation is like a shorthand representation of that graphical notation. So the region that's shaded shows us that x can be any value between 3 and 15. Now the second case that you can have with an absolute value inequality is the case where the expression, the absolute value of the expression, is greater than some constant. So in our case, we have an absolute value expression that's greater than 2. And that will look like the region shaded below, which means, let's think about this. On the right side, everything to the right of that 2 is going to be a distance from 0 that is greater than 2. And on the left side, everything to the left of that minus 2 is also going to be of a distance from 0 that is greater than 2. So that region represents the values whose absolute value is greater than 2. So this is what the second case would look like. x is greater than some constant. That's on page 566 in the purple box in your e-text. Now here's the region again. Instead of the middle portion being shaded, we have the outer areas being shaded to the left of -2 and to the right of 2. So that helps us now remove those absolute value symbols. If we just translate the graph, we've got the expression being less than -2, or the expression could be greater than 2. So let's start with the expression that was less than -2 and solve that. First we have to add 2 to both sides, then we get 2/3 x is less than 0, and the only value of x that could make that true would be x is less than 0. Now let's take the second expression. 2/3 x minus 2 was greater than 2. Add 2 to both sides, we get 2/3 x is greater than 4. To undo times by 2/3, we multiply by the reciprocal 3/2 on both sides of the equation. The 2/3 cancels, and 2 goes into 4 twice, and the 2 times the 3 gives us 6, so we have x is greater than 6. So the solution to our absolute value inequality is x is less than 0 or y is greater than 6. I'm sorry, that should say x is greater than 6. Now you can see graphically what this looks like. X less than 0 is the region to the left. X greater than 6 is the region to the right. Now, since it's not a region that's joined all together, we have to join them with that union symbol when we write the interval notation. So our interval notation reads, we use the rounded brackets again because it's not less than or equal to, it's just less than. So the interval notation says x is anything between 0 all the way to minus infinity. So that's that left-hand portion on the graph. Joined with union, that's the translation of the or here, all the values of x between 6 and positive infinity on the right. So again, you see here how the interval notation is a nice shorthand notation for that graphical notation. Okay, so there's 3 ways again of writing the answer.